Now that management CA has been set up, which you may only use for your administrative actions in EJBCA, alternatively you can of course roll it out and use management CA as your primary CA across your installation in other web applications or any use case you might have. But on the other hand, you might want to create separate CAs for each of your business application. For an example, one of the CAs can be issuing certificates to your web applications in Kubernetes, perhaps with Cert Manager, with which EJBCA has a good integration. There can be business applications with IoT devices, and you might be using another CA. The devices might be running in different regions. You might be setting up different sub-CAs for each of these regions. And you can also take advantage of other protocols, for an example MSA, to roll out certificate for your workstations. So what are we going to do? The similar things as before. We are going to create a new crypto token as before. We are going to create the CA, get it signed from a root CA which is stored offline. Perhaps this offline CA instance can be set up with software or hardware appliance or EJBCA as just running as a software. Please look into this deliverable or packagings for EJBCA2. This is a very important part of the PKI to store the root CA as securely as possible. So we will do that. We will be setting up new certificate and entity profile, which is EJBCA resources, to properly configure what certificates, what kind of attributes will go into the issued certificates. We will finally enabling REST API. We will show how to issue a certificate with this issuer CA. We will also be configuring the domain. We will configure a new domain name. So for an example, if you are having an IoT device which is requesting a certificate using ESD, it does not need to know about management CA. So that is why we will be issuing a server certificate. So let's go ahead. So let's create our first crypto token. So it is very similar to the operation we did before. We are going to use token 1 because you might remember that's where we created the keys, and we are going to use the key number 002 this time compared to the 001 we used last time. Oops. So token 1, we put the password foo123, save. Now we have the same keys showing up. So let's create our issuer CA now. So now select the crypto token, make sure the correct keys are selected, and for signed by we select external CA because that's where our root CA is. It is not internal to our EJBCA. So we download the CS certificate CSR. Now that our issuer CA has been created and it has no certificate, we need to get the actual certificate issued from our offline instance or offline root CA. So let's go into there. Now our root CA has already been created, but to create a sub CA certificate, first we need to see how it is going to be enrolled. From the certificate profile level, we need to use sub CA certificate profile. Let's create a new entity profile so that it can use the sub CA profile. So let's create it. We need to configure it a little bit to make sure it has a default sub CA and it is allowing our root CA to enroll the certificate. Let's save it and then let's go back to RA web and select this profile, sub CA. We already have the CSR certificate, so that is why it is provided by user. We upload the CSR file and then use the same thing in the username. Now we're good to go. Download the PEM whole full chain. Now we go back to our CA instance once more. Go back to our certification authorities page where it's waiting for the signed certificate by our root CA. We scroll down and we just need to upload the signed certificate. Yeah, good to go. Let's go back to home page. Now that our issuer CA has been set up, let's go ahead and create some associated resources so that we can actually have a proper functioning way to enroll the certificates with EJBCA. We are going to create a new certificate profile for this. So we are only going to use issuer CA for the certificate profile. So let's do that. Certificate profile allows you to ensure certificate attributes. For an example, if validity is properly set, it is not like super long or super short, that kind of thing. We save them and we create an identity profile so that this certificate profile can actually be used from here. So once more, we scroll down, we ensure that this certificate profile can be actually used in here, and make sure issuer CA is the only responsible one for this. And then finally we enable REST API access so that we can actually enroll the certificate. Okay, now we are good to go. Now to issue the new certificate for this new domain with issuer CA, we go to RA Web. We do the same things as before: enroll, make new request. The same thing as before: empty certificate type, server certificate profile, but this time with issuer CA. And then again with RSA, or you can use the EC keys. For the common name, we need to grab the domain we are planning to use. So that is available in this additional host section. Notice that there is still the old host in the Nginx host section. So we copy over this domain back to here in the common name and in the DNS name. Now we populate the username with the same domain name so that we can find it out later. Notice that there is no additional DNS name unlike the last time. We put the password, confirm it. Now we just need to download the file. Now we are good to go. Now that we have the server certificate file issued by our issuer CA, we are going to do the similar steps once more. So we are going to split it up into 3 files. Same, cause like we can see the same private key, server certificate and the CA certificate in there. Just the CA certificate this time is different, just for coming from the issuer CA. So we use the same script as before to split them up. Let's run at them. And those things are created. Now we need to make sure Kubernetes is also aware of it, so we create a new secret. Notice that this time we are providing all 6 files. So the server certificate file for the test domain, so normal management CA issued certificate for the default domain, and then finally for the test domain. Notice that there is also specific nomenclature, so for -key, -ca for both the domains we have to use. Now this secret contains all 6 files now, so let's create the secret in Kubernetes. Now let's run the command. So let's see if it's good to go. Now we need to redeploy EJBCA with this updated configuration. Here we have a separate file for that already, and we are going to add this additional host which has this issuer CA issued certificate. So the same secret is also needed to be updated, because we create the new secret, we have to update the Helm chart values YAML for that thing too. Let's do that. Save. And now let's do Helm upgrade. So okay, let's see if everything is good together. We grab the comment again. Seems like the pod 1 is terminating. We will wait for a little bit, then we'll. Now that EJBCA is up and running again, let's take a look into what certificates are being used. Let's jump into our admin web with the same IP address as before. So let's reload this page. Okay, let's clean up a little bit. So let's see the certificate. So now it is pointing to the default domain, so it's not pointing to the additional host we have just put in for issuer CA. So the same certificate we have configured over here is showing up over there, issued by management CA as expected. Now, so that we can access these two other domains, so issuer CA dot AC, this thing, let's configure our local DNS entries a little bit. So we edit the etc hosts file. In your case, it can be some DNS entries in production settings. So we kind of already have this configuration before I actually did a test run with this. So both of these domain can be used to access the same IP address. So let's do that. So we copy over this domain name from somewhere. Let's check, do it from here for clarity. So HTTPS once more, and it is redirecting to us to EJBCA. So it gave us the option for certificate authentication with management CA or the super admin we had. So it's the same thing as expected, issued by management CA. Now let's do the other one. So with the test domain, we grab the domain name once more in the browser with HTTPS, and let's see. Now it does not have the super admin certificate. Instead of it points to some other certificate we had before for our root CA, because issuer CA was also issued by the root CA, so that is why it kind of prompted. But at the end of the day, there is no certificate issued by issuer CA as super admin. So we can see the certificate is properly being used, the server certificate issued by issuer CA. But we cannot log in because we do not have any super admin from that their issuer CA. So that's about it. The TLS certificate is properly configured. Now if you have a IoT device, for an example using EST with this issuer CA, it does not need to be aware of any other domain than this one. So let's continue in the next step.